People smarter than me. All right. So we got 6 carbons here, and here we also have 6 carbons. Now, I'm not going to try to draw out the complete structural formula. It gets a little bit complex when you put it in a circle like that. Okay? I could do the condensed structural formula, but showing those hydrogens is a little bit complex too. But a cyclohexane just means it has a bond all the way around. It doesn't just stop right here. Okay? Now, there are some really important structures that are based on these cyclic sort of things. Okay? But we're going to save that to finish up with that tomorrow. Okay? Here's what I want you to do for tonight. Okay. Yep. 3 questions. All right. Let me give you a quick introduction to this. Okay? In order to do this, you have to be able to draw 3-dimensional structures as we did in Unit 3. 3-dimensional structures. Okay? All right. Remember when we did, say, methane? Look like this.
Oh, yeah.
All right. What did water look like? Okay. Don't put anything away yet. I'm not done. Shh. All right. Here's what's new to this. Remember Unit 2 when we did periodic properties. If you'll find your test references, underneath the common ions list is a periodic table of electronegativities. You looked at this already at least once. Get your test references out and look at this. All right, listen. The electronegativity for oxygen is 3.44. You need to be quiet and listen. You are disrupting class, making it hard for people to learn. The electronegativity for hydrogen is 2.1. When we subtract these, we get 1.34, which I've taught you to round off to 1.3. Okay? Now, No, we're looking at the 1.3 electronegativity difference. Electronegativity difference for a bond between hydrogen and oxygen. Okay? All right. So this part's subtraction. All right. This is on page 178 in the stuff you're supposed to read tonight. Study, okay, and use this as your guide. 1.3 electronegativity difference is in the range we call polar covalent. Okay, that's polar covalent. Between 0.5 and 1.5, and that's between that, right? Yeah. Okay. So that means these bonds are polar. Okay, so the bonds are polar. Okay. These bonds over here in methane are evenly distributed. Okay? They're evenly distributed. That means for every bond, there's an equally spaced bond in every direction. But not here. And here, there's 109.5 degrees to this, but a much, much larger angle over here. So these bonds are polar, and the bonds, I said not to put things up. You are disrupting my class. Please be quiet and be still and listen. You're not going to leave till I let you go anyway. All right, so the bonds are unevenly distributed. Okay? These are evenly distributed. These are unevenly distributed. Both of these together, you have to have both of these to make a polar molecule. And that's what these questions are asking you, to find the shape of the molecule and determine whether it's polar or not. And that's really all there is to it. Okay? All that instruction, in case you need it, is found on those pages I assigned, 177 through 180. I pretty much told you how to do it. I would highly recommend that you go back over it. Now you may pack up.